Hey, this is Mr. Drogemeyer. Thanks for joining me today for our Algebra 1 lesson videos. Today we are in Unit 4, looking at lessons 16 and 17, rate of change from an equation. And in these next several lessons, we're going to be talking about rates of change. The most common rate of change that we talk about is slope. But for these particular lessons, we're just going to focus on that term rate of change. And we've got both a definition and a formula here. So an average rate of change is going to be measuring how much a function changes on average over a certain interval. So our interval they gave us here is from A to B. We want to know how is that function changing when we go from A to B. We can use the formula then, f of B minus f of A divided by B minus A to find that. Well, so if I have a function, just as an example here, let's say that my function is f of x equals 2x plus 1. And I want to know what is the rate of change on the interval from, let's do it this way, from 1 to 3. So what is that rate of change? Well, I would need to know what is f of 1, what is f of 3. Well, f of 1, that's just going to be what do I get when I plug in 1 for x? Well, 2 times 1 is 2. 2 plus 1 is 3. So f of 1 is 3. F of 3, that's going to be what is the value of the function when x equals 3. Well, 2 times 3 would be 6. 6 plus 1 is 7. So once I know what f of 1 and f of 3 are, then I can go ahead and plug those into my rate of change formula. So okay, and our intervals here, B was the last number, A was the first number. So here, 3 is going to represent B, 1 is going to represent A. Sometimes it's just getting through all of the code here that we've got to figure out what we're doing. So f of B in our formula is actually what is f of 3 here, which is 7. F of A is our f of 1, which we said is 3. B is 3. A is 1. So to find my rate of change, I've got 7 minus 3 in the numerator, which is 4, 3 minus 1 in the denominator, which is 2. And so the rate of change, or slope in this case, for this particular function that I gave us, the slope is 2, or the rate of change is 2. So we want to do the same idea here with these example problems. So it says, given the function with f of 5 equaling 105, f of 1 equaling 65, determine the rate of change over the interval from 1 to 5. And so again here, 1 is our A term, 5 is our B term. F of 5, that represents f of B. F of 1, that represents f of A. So if that helps you to be able to visualize that, I would recommend that you label those for you. So f of 5 is 105. F of 1 is 65. So in our numerator, that's our f of B minus f of A, 105 minus 65. Our denominator, we take B minus A, so that's 5 minus 1. And now we're going to do those operations and simplify. So 105 minus 4 or minus 65 is 40. 5 minus 1 is 4. 40 divided by 4 is 10. So our rate of change for that function from 1 to 5 is going to be 10. Our last example here, they want to know what's the value of f of 3 if f of 1 equals 8 and the rate of change from our interval from 1 to 3 is 7. All right, so this time we know the rate of change is 7. To get that rate of change, we would have been taking f of 3 minus f of 1. Well, f of 3, we don't know what that is. F of 1, they told us, is 8. And then in our denominator, b minus a, that would be our 3 minus 1. All right, and so now we're going to need to kind of solve this as an algebraic equation. We can simplify that denominator. So 3 minus 1 in the denominator is 2. We want to try to isolate f of 3. So I need to multiply each side by 2 because I want to get that f of 3 by itself. So now I have 14 over here. On this side, when I do that, those cancel to 1, and I'm just left with f of 3 minus 8. And then finally, my last step would be to add 8 to each side, which gives me 22 over here, and just f of 3 over here. So f of 3 would need to equal 22 for that rate of change to be 7. All right, and that's all I've got for you guys today. Appreciate you taking the time to watch. As always, if you have questions, please let me know. Thanks. Have a great day.